Hello, in this video we are going to look at a couple more examples of using just the power constant and sum and difference rules for derivatives to take derivatives of things that don't necessarily look like a power constant and sum and difference. So this first one looks a lot like a quotient, and we will later on learn a quotient rule, but this one we can actually do without employing the quotient rule because we have just a single term in the denominator of our function 2x cubed minus x squared all over x squared. Since we have just a single term in the denominator, we can split this up and write this as 2x cubed over x squared minus x squared over x squared, and simplify that fraction to 2x minus 1, which is much easier to take a derivative of than trying to do the quotient rule, which for my students we'll be learning in the next section. So if we want to take the derivative of this is going to be 2 times x to the first. Derivative of that is going to be 2 times 1 times x to the 1 minus 1. 1 minus 1 is 0. And then the derivative of negative 1, that's like an x to the 0. So if we use the power rule, we're going to bring down that 0. And so we get the derivative of any constant. Anytime you have a derivative of something added or subtracted that does not have your variable in it, that derivative is always going to be 0. So this derivative simplifies to just 2. All right, our next example, we're looking at the function f of x equals the quantity 2x minus 1 times the quantity x squared plus 3. This one, you could use a product rule, but we're going to focus on looking at this in terms of just the power constant and sum and difference rules. And so before we can take the derivative of this, we need to multiply it and expand it. So we take the derivative of 2x times x squared, 2x times 3, negative 1 times x squared, and negative 1 times 3. Now we have this in an expanded form. Now we can apply our derivative rules. And so the derivative of 2x cubed is going to be 2 times 3x. 3 minus 1 is 2 for our new exponent. And then 6 times x, that derivative is going to be 6 times 1x to the 0, so that's just going to be 1. And the derivative of x squared is negative 1 times 2x to the 2 minus 1, which is 1. And then the derivative of negative 3 is a constant. Negative 3 is a constant, so that derivative is 0. So if we clean this up just a little bit, and most of you won't take too long before you're skipping the step that I just did and going straight to the answer. In this case, 6x squared plus 6 minus 2x. Or let's go ahead and write that in standard form. 6x squared minus 2x plus 6 would be our derivative. All right, let's look at one more. The derivative of the function x squared plus 8 quantity cubed. So we need to do the same basic approach we did on the last one, but we need to multiply that out 3 times. That is actually a formula that we can use if we have a binomial a plus b cubed. It's always going to multiply out to the first one cubed plus 3 times the first one squared times the second, plus 3 times the first times the second squared, plus the last one cubed. So if we apply that here, x squared is going to be our a. So x squared cubed, that's a power raised to a power. So we're going to multiply those exponents. 3 times the first one squared times the second, plus 3 times the first one times the second squared, plus the last one cubed. All right, so if we clean that up just a little bit, x squared cubed, power raised to a power, we're going to multiply those exponents and we get x to the 6th. 3 times x squared squared times 8 is going to be 24 times x to the 4th. And then 3 times x squared times 8 squared. 8 squared is 64 times 3 is 192 times x squared. And then 8 cubed is 512. All right, so now we have this in the expanded polynomial form. Derivative of this is going to be really straightforward. I am going to go ahead and skip steps a little bit just to streamline this. So x to the 6th is going to be 6 times x to the 5th. 24 times the derivative of x to the 4th is going to be 24 times 4, which is 98. X to the 3rd, let me correct that, 96 x to the 3rd. 192 times 2, I'm going to not have to correct this one, 384 times x to the 1st, and then the derivative of the constant 512 is 0. So that would be your answer. All right, I'll see you guys next time.